for Linux CBT, and then paste it. So fields in etc shadow, for example, includes username followed by, and it's usually MD5, but we won't list MD5 because it could be SHA or some other algorithm. So we'll just indicate encrypted password. So the ABC123 that we typed in earlier is represented by these characters, $ all the way through the terminating 0, and the delimiter here is colon, which you could use awk to parse real simply, followed by the days since the Unix epoch the password was last changed. So days since epoch password was changed. And since we're going to run out of space here, let's place each of these fields on a distinct line. So we've got the first field being username, second being encrypted password, third being the days since the Unix epoch the password was changed. The Unix epoch was 01/01/1970. So 13,891 days have passed since the Unix epoch, since the user's password has yet to be changed. Or was changed, that is, since we just changed it to ABC123. So it was changed 13,891 days after 1970. The fourth field, which currently has a 0 in it, the days before password may be changed. So days before password may be changed, which in a secure environment should be at least 3 to force a user to hang on to a password before having the option to change it. And that's represented by a 0 here, which means the user can change his password multiple times in any given day without being penalized. The next field, which has the 99,999, represents the days after which the password must be changed. In other words, this is a value that's typically 30, 45, 60, or 90 days in most corporate environments. This is the total number of days the user may hang on to a password, which should be reduced. And the effective way to do so is via etclogin.defs. In the security section, when we increase the security or improve the security posture of this box, we will reduce and increase, or lower and increase some of the numbers, depending on the field, of course. Now in the next field we have 7, and we mentioned that this represents the days before the password is going to expire, that the user is to be warned. So 7 days before 99,999 days, the user will be warned that the password will be expired. The next field, which is currently blank, and that represents the spot here, represents the days after password expires that the account is disabled. So days after password expires, that account is disabled. So you may want to offer a grace period to your users, after which point the account is definitely locked out. The next field, which is the second to last field, represents the days since the Unix epoch that the account has been disabled. So days since Unix epoch, which as mentioned is the 1st of January 1970, that the account is disabled. And you can disable an account using the user mod command. The final field is a reserved field, which means it's currently unused. So currently unused. So those are your 9 fields from the shadow file. When you combine these 9 fields with the fields from etc password, you then get the full database, or the full row or record for a user in a standard user accounts database on a Linux system. Ditto applies to most modern Unix systems such as Solaris. Now there are other utilities available to help us manage users, other shell-based utilities. Supposing we wanted to modify some of the properties of the current user. So let's set a second task. Modify user student1 to password expire after 45 days. And that's where we'd use the usermod command. Let's take a look at usermod. We'll clear screen and execute usermod with no options, which returns the options that are available. You can even set an expiration date. You can change the home directory, set password inactive after expiration to inactive, force a user to have a primary group, or append any number of supplemental groups. You can lock the user's account using upper L or -- lock, which prevents the user from logging in. You may move the contents of the user's home directory to a new location, providing you use option lower D to indicate where the user's new directory will be, which will perform a move of the user's items in one step for you. You can change the user's shell. You can specify an encrypted password, which will function as the new user's password. You can map a user using SE Linux, so a user to the current Linux user, since they're separate entities. And you can even make the change that we're proposing manually via the shadow file. You could even use a tool like awk to make the change automatically to all users. So let's take a look at the shadow file. A nano of shadow, and you can set the expiration date, which would achieve a similar function. Let's navigate to student 1 and just update 9999 to 45. Now this user will have to change their password by the 45th day. So in other words, 45 days after today. So that user's account has been updated manually the old-fashioned way. Now with that said, let's show you how to manipulate the groups on the system before we use the graphical tool to manipulate both users and groups. Primary utility is group add, but group add also includes group mod, which allows you to change membership information, and so does user mod, by the way. Using the uppercase G option, you can indicate supplementary groups by delimiting them by commas or using commas. So, how do you know or determine what groups are available on the system? Well, group add will add new group. However, the simple group command lists the groups on the system, and this is groups plural, will list the groups on the system. So this lists groups on the system. But we're on the system. Well, again, we're in ETC. If we LSL group, you'll see there's a group file which contains the groups defined on the system and the associated members. So this information comes from ETC group. ETC group maintains group membership information by simply enumerating with a comma delimiter the members of the group. So, for example, we see groups that belong to users of the system. Linux CBT Student 1, this is the methodology employed by Redhat for grouping users. But sometimes you want to create general purpose groups, such as sales. So our task will be to create a sales group and add Linux CBT and Student 1 as members. Because through group memberships, we can assign permissions to different folders or directories and or files throughout the file system. So to implement this task, we'll use group add